This is the question which is based on Young's double slit experiment. The rays are falling at an angle alpha. Then the slit separation is given as 0.3 mm. The distance between the slit and the screen is 1. Then the wavelength of the light is 600 nanometer. If you solve it, it turns out to be 0.6 into 10 raised to minus 6 meter. And we have to choose the correct options among this. Now first of all, if I see the option for alpha equal to 0.36 by pi, for alpha equal to 0.36 by pi, these are the two things, and we have to check at O and P what we are getting, whether destructive interference or constructive interference. And next option says that the fringe spacing depends on alpha, and one of the options says that for alpha equal to 0 what will happen at P. So for that, first of all we will try to find that what is the d sin alpha and d sin theta values, because that is what is going to be a path difference when this ray and this ray is going to reach at point P. So d sin alpha plus d sin theta will be path difference when it will be reaching at point P. If I am talking about point O, then d sin theta will not be there because these rays are not having any path difference, and I'll have to only consider d sin alpha. So first of all, we will try to find what is the value of d sin theta. Now for d sin theta, if you substitute the values, this theta is very small, so I can write d sin theta is same as d tan theta, which I can write it as this 11 upon 1, but it is in millimeter, so to convert it into meter, it is 11 into 10 raised to minus 3. How much is the value of d? It is 0.3. So 0.3 into 11 into 10 raised to minus 6, because this will be 0.3 into 10 raised to minus 3. So this will be 3.3 into 10 raised to minus 6 meter. So this is a path difference which you will get for this right side part. Now if you try to find this d sin alpha, then this d sin alpha will almost be equal to d alpha for the small alpha. Now for alpha equal to this, so d, I'll substitute 0.3 10 raised to minus 3, and for alpha equal to 0.36 by pi degree, so I'll have to convert it into radian. Now how you normally convert it into radian? For 180 degree, it is pi radian. So for 0.36 upon pi, these many radian. So it turns out to be 0.3 10 raised to minus 6 into 36 upon 18 into 10 raised to 3. I have just done the adjustment for the decimal point. So here 36 by 18 will be 2, so it turns out to be 0.6 into 10 raised to minus 6. So this is the part difference which you are going to get because of the left part. Now the fringe spacing depends on alpha. So remember that in such cases you never have different fringe spacings for different alpha. The beta always remain constant, it is lambda d by d. Hence this is not the correct answer option. Now for alpha equal to 0, he is saying that constructive at the point P. Now I'll have to check that for alpha equal to 0 there will not be any d sin alpha. So it will be having only d sin theta. Now d sin theta turning out to be 3.3 10 raised to minus 6. So if I divide by lambda, because this path difference, if it is an integral multiple of lambda, it is constructive. If it is 2n plus 1 lambda by 2, where n starts from 0, then it is destructive. So I'll have to check that what that number is coming out. And hence, for every part difference, I'll be dividing by lambda. So here, for this option, I'll have to check that 3.3 into 10 raised to minus 6 divided by the wavelength. Now how much is the wavelength? 0.6 into 10 raised to minus 6. So what I get is 33 by 6, which is nothing but 11 by 2. Now this is 11 by 2 means it is turning out to be of the form 2n plus 1 by 2. Hence it is a destructive interference, and hence this is not the correct answer. Now I'll again want to check that for alpha equal to this, destructive or constructive at point O and P. Now I'll first go for O, because when I go for O, obviously there will not be any part difference due to this right side. So d sin theta I'll have to consider it to be 0, and now I'll only consider this d sin alpha. So again what I'll do, I'll have to divide this by the wavelength. So it will be 0.6 into 10 raised to minus 6, and wavelength is again 0.6 into 10 raised to minus 6, which turns out to be 1. It means at point O, it must be a constructive interference, but they are saying that it is destructive interference. So definitely this is wrong. Now obviously the only option remain which will be correct is going to be C. So do not have a second thought and mark a C option, but we'll just verify it. Now for point P, I'll have to add this both the part differences. So add 3.3 into 10 raised to minus 6 with 0.6. So it turns out to be 3.9 into 10 raised to minus 6 divided by wavelength. Now how much is that wavelength? 0.6 10 raised to minus 6. So it turns out to be 39 by 6, which is nothing but 13 by 2. So it is again of the order of 2n plus 1 lambda by 2. Hence it must be a destructive interference. And hence the answer option for this question will be only C option.